Damir Barnes' first watch as third officer aboard the tanker Joshua Slocum was one he would never forget. At 2300 hours, radar detected a target dead ahead. It was large, not making way, and right on the track dictated by the passage plan. The chart showed nothing in that position. At 2306, Damir confirmed that the radar target was an oil rig. He looked for the master's night orders, but couldn't find them. To avoid the rig, he deviated from the passage plan by altering course to starboard. At 2309, he spotted a second rig. This one was further ahead and inshore of the first. But Damir was confident that the Joshua Slocum would be able to pass between them comfortably. But then the lookout spotted something else. The navigation lights of another vessel. They'd been lost among the second rig's working lights. The two vessels were in a crossing situation. Damir knew he must give way because the other vessel was on his starboard side. He also knew that the customary response was to turn to starboard. But if he did that, he would then have to leave the second rig to port as well. Was there enough depth to do that? A quick decision was needed. Unfortunately, Damir took the wrong one. He turned to port. It was 2310. Fully laden, the Joshua Slocum turned much more slowly than his last ship. At 2313, the ships were only cables apart.
Captain, coming on the bridge, quickly!
The master was only halfway to the bridge when the vessels collided. Human error. Human error costs the industry over $400 million a year. Far more in lost time, lost business, lost jobs, and lost reputations. Worst of all, people are injured and killed, and their families shattered. It's a tragedy, because many human errors need never end this way. Damir Barnes, the Joshua Slocum's third officer, survived the collision. But he couldn't get another job at sea, and he was ridden with guilt. If only he'd called the master when he spotted the first rig. If only he'd slowed down. If only he'd studied the chart more carefully, because in fact there was plenty of water further inshore. But while Damir held himself responsible for the collision, his error was not the only one. Damir had joined the Joshua Slocum shortly before it sailed. The master was swamped by people and paperwork. Cargo matters were keeping the chief officer busy.
I would like the people to stay clear of this hose until he's heaving up it.
The second officer was immersed in the passage plan. All three would unwittingly contribute to the collision, as would the ship owner's office staff. It was pressure from the office to save time that led the master to take a calculated risk.
But we will arrive too late, so we will have to cut some corners. We have to go a little bit faster.
Only what we can do is...
Cutting a corner would mean entering an exclusion zone, a future oil field. But there was nothing on the chart to suggest that exploration had started.
Last time I passed, there was nothing there, so we can easily go there, no problem.
Yeah, then, okay, Captain, then from here...
The second officer was uneasy about this, but didn't question the master's decision. The chief officer had been on duty for 36 hours, but still found 5 minutes to meet the new man. He was impressed. But 5 minutes more would have revealed that the young man's book learning wasn't matched by experience.
I've come to investigate the accident which happened.
Nobody enjoys investigations.
Did he wear a safety harness?
I said to him, always must be used, but they don't. This time they don't. Sometimes they do, but this time...
Are all the crew members being made
Often,
aware?
the investigators seem content to identify and blame the person most obviously responsible.
Without belt.
The root causes remain hidden. Remedial action will work only if the very same thing happens again. To a team of researchers in England and the Netherlands, that looked like shutting the stable door after the horse has bolted. They believed there must be a way to pinpoint root causes before they could do damage. A way to prevent the next incident occurring, not the last one. It took years, but with help from UK P&I Club member Shell, the team succeeded.
There's a small hole, sir, that causes for the leaking.
They call the immediate causes of incidents active failures, and the root causes latent failures. An active failure, something that happened at the sharp end, is generally blamed for causing an incident. But the researchers found that latent failures are a greater threat. They create the conditions in which active failures are more likely and more serious. Latent failures frequently stem from decisions made higher up. For example, many cases of cargo damage are caused by not replacing worn-out hatch cover seals. Like diseases, latent failures can hide in the system for years, so no one knows how many accidents are just waiting to happen. To detect them before loss or injury can occur, the team simplified the complex workings of organizations into clearly defined categories. The first was procedures. To bring latent failures to light, questions to ask include, are clear standardized procedures available for all routine tasks? Hardware. Is the ship and its equipment up to the job? Design. Is bad design encouraging unsafe acts? Maintenance management. Is maintenance ever delayed or poorly planned? Error enforcing conditions. These are factors that make mistakes more likely. Pressure of time is one. Fatigue is another. So are too little or too much information. Poor working conditions. Low morale. Housekeeping. Housekeeping speaks for itself.
Gas tight fitting. It isn't.
Well, if necessary,
It may seem trivial, but the UK club inspectors find it a reliable indicator of the general quality of a ship. Incompatible goals. Is anyone struggling with incompatible goals, such as conflicts between safety and productivity?
We had at places 2 interlocking coils.
Written procedures and local ways of doing things. The demands of the job and personal distractions. Communication. Do channels of communication exist? Is the necessary information transmitted?
This way?
This way is good. And the light way is no good.
Is it understood?
No good.
No.
Organization.
Good afternoon, gentlemen. At first, we sailed Southampton.
Does the way a work group is organized encourage contributions from all its members?
There is no problem. Temperature is in good condition.
Training. Do people have the skills they need? Not just through formal training, but on-the-job coaching as well. Defences. Last, but not least, the measures designed to control and contain hazards. Will they take the sting out of the consequences of failure? Let's review the Joshua Slocum's collision in the light of these lessons. The UK club finds that 90% of collision incidents are a result of human error. Where did things go wrong in this case? There were error-enforcing conditions, incompatible goals, and a failure of organisation. Damir was right. Slowing down and calling a more experienced officer for help might have prevented disaster. That's what the night orders would have told him to do. They were in their usual place, but Damir had missed them. He'd had barely an hour to familiarise himself with the ship. That's about par for the course, according to UK club statistics. Is it really enough? Damir's inexperience and lack of familiarisation are error-enforcing conditions. So are the excessive workload and fatigue, which prevented the chief officer giving the new arrival the attention he warranted. Fatigue causes countless incidents. It's a problem that won't go away unless manning levels are geared to operational needs, not regulations or tonnage. A sea of forms, lists, reports and emails threatens to drown the industry. But no piece of paper is as important as the charts and navigational publications. All too often, the UK club's inspectors find they're uncorrected or out of date. That's a failure of organisation. Had they been routinely updated, the Joshua Slocum's officers would have seen that the oil field was now active. At the core of this case is a latent failure in the category incompatible goals.
Captain, coming on the bridge quickly.
Masters must never allow commercial pressures to push them into taking so-called calculated risks. Ship owners' shore staff must appreciate that good seamanship is always good business. Let's look at another case. A container ship docked, expecting to replace part of its lashing gear, which was badly worn. But the chief officer found that the new equipment hadn't arrived. The agent said it would catch up at the next port of call. There weren't many boxes to load, so the chief officer concluded there was just enough serviceable gear to lash them satisfactorily. Predictably, more cargo arrived at the last minute. The lashing gang had to cannibalize some cast-off fittings to get the last few boxes secured.
This one is not good.
The chief officer was dubious.
I have a problem with those broken twist locks. I don't think we can use them on the containers.
But as the stevedore said, the weather was fair and the next port just around the corner.
Okay, it's no wind. We'll do it just for one time.
But the fair weather didn't last. As the seas grew higher, the next port seemed a long way away. And where was the stevedore when the stow collapsed? The UK club finds that 50% of cargo damage incidents are a result of human error. Where did things go wrong in this case? There were failures of hardware and maintenance management. Error-enforcing conditions were present, and incompatible goals. There's no doubt it was a bad day for the chief officer. But what were the latent failures that made this an accident waiting to happen? Unless the right tools and equipment are available and in working order, you're inviting a failure in the category hardware. Maintenance that's delayed, missed, or poorly planned is guilty in many incidents where human error gets the blame. What makes an experienced, responsible chief officer load more cargo than he can properly stow? The answer is the error-enforcing condition that's an everyday experience: commercial pressure. He was so used to it, it simply didn't occur to him to refuse the additional cargo. That day, the chief officer learned 2 lessons the hard way. Commerce should never override good seamanship. And what suits people ashore won't always suit the ship. Far too often, human error leads to injury and death. A new able seaman on a ro-ro had little experience and less training. He'd paid cash for his counterfeit certificate.
Zostaw, to mam dla ciebie inną pracę.
The bosun already had misgivings.
Nim pójdziesz tam, powinieneś iść do biura.
When a ballast tank had to be prepared for survey, he warned the newcomer to study the tank entry procedure and follow it to the letter. Unfortunately, all the procedures were in English, which the able seaman couldn't read. To save face, he improvised. Not expecting to be in the tank long, he posted a man at the entrance to keep an eye on him. It was a risk that didn't pay off. In less than a minute, the able seaman collapsed.
Adam? Adam!
Rather than follow him into a potentially toxic environment, the other man sensibly alerted the bosun. Hearing that the breathing gear hadn't been used, the bosun ordered him to fetch it. But that wasn't so easy. Access to the locker was blocked. Instead of waiting, the bosun went in, trying not to breathe. By the time the rescuers arrived, there were only bodies to bring out. The UK club finds that 60% of personal injuries are a result of human error, mainly the crew injuring themselves. Where did things go wrong in this case? There were failures in procedures, housekeeping, training, and defences. Sometimes it's the way ships are designed that turns a simple human error into a catastrophe. A chemical tanker was discharging when the chief officer was called by the terminal.
Command 63.
Yes, this is ship. Go ahead. Stand by here. We're trying to spot it right now.
They wanted to top off some shore tanks. So he did as they asked and reduced pumping pressure. He called the terminal to confirm that he'd done it.
Master, we reduced the speed. Over.
Moments later, he was distracted again.
Look, Chief, we're never going to get number 5 finished before you sail, so can you have a look at it?
He left the radio behind. Then, the engineer left the room, knocking a pump control lever fully on.
Command 63.
The terminal tried to alert the ship. In vain. Normally, a seaman monitored the pressure gauges at the manifold. But he'd been called away to help set up a backup pump because one of the cargo pumps had failed.
Boy, we know we're gonna run out. I said one more.
The chief officer returned too late to stop a shoreline failing. The cleanup cost $250,000. Pollution incidents are infrequent, but costly. Where did things go wrong in this case? There were failures in design, communication, organisation, and defences. The active failure was the accidental increase in pumping pressure. But the incident would never have occurred if the console had been designed to prevent the controls being moved unintentionally. Leaving the radio in an empty control room led to a basic failure of communication. There was a built-in defence, the man monitoring the pressure gauges at the manifold. But crew numbers that are just enough when all goes to plan can't always cope with the unexpected. In fact, the master had previously reported the faulty pump to the ship's managers. They decided to postpone repairs until the next dry docking. They didn't realise how serious the consequences could be. In our final case, the pilot was late.
Third job today already, so...
When he arrived, it was the first surprise the master would have that night.
Case, Bucker.
Case.
Leslie, long time no see. When was that?
Manila.
Manila, yeah.
It's all right, check him out. We don't need that. It's Case Backer, his old shipmate.
The tide was ebbing fast, so they lost no time getting underway.
Bridge forward, bridge aft, pilots on board, single up 1 and 1 each end.
Soon they were following a zigzag track between the islands of the Delta. The second officer did her best to keep an eye on their progress, even though it seemed to amuse the old salts.
After sort of...
Then a light she'd been expecting to see didn't show up.
-3 golf balls. It's all in.
One that could not be easily missed on a clear night like that. Or could it? She supposed it was out of order. The pilot would know that, of course. But the doubt wouldn't go away. And the second officer plotted another GPS position. It showed they'd missed a wheelover point and were moments away from running aground. The ship was hardly scratched, but damage to the coral reef cost $500,000. The increase in incidents attributed to pilot error is a matter of concern. But pilots don't work on their own. Where did things go wrong in this case? There were error-enforcing conditions and failures in communication and organisation. Commercial pressures act on pilots as well as ship staff. Time was on nobody's side. Was it that, or other factors that made two experienced mariners negligent? In an ideal world, masters would brief pilots about the handling characteristics of their ships, and pilots would detail their plans before the handover takes place. In the real world, the pilot conference often amounts to little more than a handshake. But commercial pressures don't do away with the need to exchange this information. It makes open communication between pilots, masters, and officers even more vital. Does it really happen? Canada's Transportation Safety Board thinks not. It asked hundreds of masters and pilots, do you communicate well? Yes, said 80% of both groups. So, do pilots tell masters their plan? 51% of pilots said yes. Only 24% of masters agreed. Do masters explain how their ship handles? 75% said yes, but only 19% of pilots agreed. Question after question confirmed that the perceptions of each group were in conflict. Why? Perhaps the masters assumed the pilots knew all about their ship. Maybe the pilots believed the masters were familiar with the waters. The researchers' conclusion: neither group expected to give much information or receive much in return. On the bridge, a keep-it-to-yourself culture can only lead to calamity. That's because communication is the driving force of teamwork, and teamwork is essential to safe navigation. No one can play a full part in the bridge team until the master champions open communication. Each member must feel free to challenge the assumptions, actions, or inaction of another, whenever there's a concern about safety. The second officer wasn't alone in failing to speak up. 51% of masters claimed that they, their officers, and the pilot always work as a team. Yet 77% of their officers said they were reluctant to question pilots' decisions. Instead of second-guessing the pilot, the second officer should have made sure she knew his intentions. The master should have insisted on the ship's passage plan being berth to berth, not pilot station to pilot station. If the pilot had briefed the bridge team properly, they could have monitored progress step by step and supported his decision-making. That would also maintain their situational awareness, so they could tackle an emergency with no time wasted getting their bearings. The sea is a high-risk environment. Human error can be overcome with communication, teamwork, and commitment, ideally from the top. There is no quick fix. Changing a culture can take years. But is there an alternative? Human error costs the industry $1 million a day.
Can you please tell me what do you know about the accident?
The real costs are higher still. Wasted time.
Do you hear him cry?
Ruined reputations. Lost business. Lost jobs. Even criminal proceedings. Worst of all, thousands of injuries and deaths.
Adam? Adam!
When lives, livelihoods, and the world we live in are all on the line, there's no room for error.